This video will briefly explain how you need to deal with project 1. There are 19 variations of this project, what we also call groups. To find what group you are doing, you need to download this file, and then you will see two columns. So this is username, which is your S number, and for each S number you will find the number of the group. Although it's called group, it's not a group project. Please remember that it's an individual assignment, and it will be nice if each of you will do it by yourself. And in the end, you need to submit your individual reports. You can download file, and it is recommended. Just choose what version you would like to use. Either it's a PDF format or the same file is given as doc format. First thing that you should do is to read the description of the project. It is based on a real-life investigation. The one was conducted at Science & Cost, so some of you will analyze data from the Science & Cost project. And others will probably have to do something with Kumira. So there is another site investigation that was conducted there some time ago. Don't forget that the due date for the project submission is September 11th, which is Friday of week 8, and you're gonna get 25%. That's how much it is worth. Then you will see data. There is lots of data provided for you. All this data is result from real geotechnical investigation. You're gonna have a map, and map will have a scale here. Don't forget how to draw cross-section. You actually require to draw cross-section along this line A dash. What I would recommend is to print out this file, especially this map, and then just use a paper to draw cross-section. Please don't change the size of the map. If you change the size of the map, for example, make it a little bit larger or smaller, you'll also change the scale, and you'll probably get some incorrect data. You'll be also provided with borehole logs. Depending on what project you are doing, there are two slightly different types of borehole logs. You are still provided the same information as the type of soil or rock, depth here, and elevation. And you're also given groundwater level, which is very important. And also for some boreholes, you will see that you're also given soil origin, marine, field, or residual soil. For other boreholes where you don't find this information, you'll find this information in tables with the properties of soil, and I will show it a bit later. Also for this type of boreholes, you will see that there is results from pocket penetrometer test, and also results from vent shear test here that you will use to classify soil. You're also provided data from some laboratory investigation. You will see that there is data from grain size distribution test. You have sieves here and percentage passing. You will need to draw this data and classify soil. You're also given data on liquid limit, plastic limit, linear shrinkage. Again, this is something that you already know what to do with, and you will use it to classify soil as well. You're also given some data in tables, table 2 and table 3, about moisture content and wet density. You'll need to calculate it and also present later as part of your results. You will see that for some of the tables, you will see that it's given soil origin as alluvial. This is something again that you need to know to write about in your project report. You're also given data from compaction test. Again, you'll need to draw this data as a compaction curve, and you will need to find maximum dry density and optimum water content. And you're also given results from control test. So what happened is they did compaction, and then afterwards they took 2 samples from the compacted area. You need to decide if the compaction was well done based on the results of this compaction control test. And we'll talk about it a bit later. So this is a task to do. You have a few tasks. Basically, the part 1 is related to analysis of just data. The second part, you need to estimate stresses. And the third part deals with the embankment construction. In particular, it will be related to compaction of the soil. So let's go through each of them, and I will briefly explain what I expect you to do. The first one is you need to analyze data from field investigation, which is related to borehole data, maps. Some of you will get DCP data that you also need to plot and analyze. So in this case, as I already showed you, there is a map and there is a line A dash, and you need to draw a cross-section along this line. In the first laboratory, we talked about how to draw a cross-section. You can play it back if you want, that recording, and see how we draw a cross-section. So this is going to be the first part, the first task that you need to do. The second task is a little bit descriptive. You actually need to analyze the data from boreholes, use your cross-section and some data from site investigation. Some of you will have data from DCP tests, some of you will have data from pocket penetrometer and vent shear test. You will need to use this data and write about 1 page of analysis of the subsurface conditions. In particular, you need to tell us about type of soil, what kind of problematic soils are present in the area, what can happen during construction, what kind of problems. And also you need to look at the origin of each soil. As I already showed you, like marine soil or alluvial soil. This information you can get either from boreholes, or you can also get it from those tables with laboratory data. And also, to get a high mark for this particular task, I would like you to use some literature to support your statements. I would expect about 2-3 references. Make sure that you provide the correct references in the text. So next task is related to soil constituents. All the data that you are given, you need to analyze it, and you need to present it in table A, and I will show you a bit later what is in the table A. And the following task is soil classification. You will need to draw grain size distribution curves using the data provided for each soil. There are 3 different soils, and you need to draw curves for each of them. The data about grain size distribution can be found in these tables 1, 4, and 7. And of course, you need to classify the soil, classify based on 2 classification systems. So this is going to be the first part. The second part is related to stresses. For the second part, you will need to draw first a cross-section. And to make it easy for you, you just need to draw a cross-section for some particular borehole. In this case, for this particular project, you need to use a soil profile from BH1 to draw a cross-section. There are a few assumptions and a few data that I gave you so that you'll be able to calculate stresses. For point 2A, you need to estimate stresses before excavation. So this is a keyword, before excavation. You don't need to do any excavation, just estimate stresses before we start digging. And you need to estimate for point A, which is 2.5 meters below the ground surface. For other projects groups, you will see that there is a slightly different depth of this point A. Please read carefully the description of your project. So this is something that you should be able to do, how to calculate stresses from unit weights. And another important information that you need to remember is that there is going to be a sand layer, and that sand layer is under artesian pressure. So this task is not that simple. You will need to consider upward seepage. And the second task in this part 2 group, you need to estimate stresses during excavation, and you also need to estimate maximum cut in the soil that is possible before any engineering issues like quick conditions may occur. So for this task, if you do it correctly, you're going to get 1 point. And part number 3, you are given data from compaction test. So you just need to analyze the data and plot it. Again, you need to plot all your data. If you don't plot data, you're going to lose points. And then you need to decide if the compaction was well done. So this is the criteria: 95% of the maximum dry density, and water content, it's optimum water content plus minus 1.5%. So this is what you need to do for this project. And to make it a little bit easy for you to present your data, there's table A that you need to fill out, and also table B. Table B deals with soil classification, and table A deals with the soil constituents. So what you need to do is you need to write a description of the soil, what is written in table 1, 4, and 7. You need to provide depth, where the sample was collected. You need to provide wet density. So this comes from the report. You just need to provide average density. You're going to have 3 values, but you need to provide average. The same thing you do for moisture content. You are given data and you need to calculate water content and get the average value. Then after that, you just calculate dry density, specific gravity, volume of water, weight of solids, weight ratio, degree of saturation. And you're going to have one soil which is sandy material. So for that sandy material, you're also going to get relative density and classify it. Don't forget to classify it. It can be dense, loose, very loose. We did it in lectures before. And if you're given data with DCP test, I also expect you to do some estimates of soil strength. So just try to relate the number of blows in this DCP test to the strength of soil. For table B, what you need to do is the same thing. You just provide a name of the soil here, then depth where it was collected. Then you need to decide on the percentage of each fraction, how much you have gravel, sand, silt, and clay. Then you need to classify it based on the AASHTO classification system, and the same thing but using unified soil classification system. You're going to have 2 plastic soils, and only for 2 plastic soils you're going to do plasticity index, and you're going to get liquidity index and also classify it as well. Don't forget to classify, and also activity and classify. So when you have sand, you don't need to do it for sand. For sand, you only do the relative density. This is the marking criteria. Before you submit your report, please read it carefully. For each task, 1A, 1B, 1C, there is marking criteria. So what you need to do to get a full mark, and you need to draw cross-section correctly. You need to identify all geological units. You also need to determine the groundwater level. Then you need to make sure there are no mistakes. Everything is spelled out, no symbols that we don't understand, and no spelling mistakes. So please read it very carefully, and before you submit your project, that's what you need to do.